this problem we have a 3-gram copper penny drops a distance of 20 meters to the ground. It says if 75% of the initial potential energy goes into increasing the internal energy of the penny, determine the magnitude of that increase. Now, in these types of problems with internal energy, it's not really a formula that we go to that's new. Instead, it'll tell us how to go about solving the problem. In this problem, it says 75% of the initial potential energy goes into increasing the internal energy of the penny. So all we have to do is find the initial potential energy and take 75% of that. So you have to read carefully about what to do within the problem. You can't just look for the numbers. We start, of course, with a diagram. We have a picture. We have a penny that is 20 meters above the ground. We have our givens. The mass is 3 grams. We're also given that the height is 20 meters. We want to figure out what is the change in the internal energy. How much did the internal energy increase? So that's a delta U. But before we do that, we have to actually calculate the potential energy. And the potential energy, the formula is mgh. It is the mass times the gravitational field constant, 9.81, times the height. The only problem with proceeding here is that our mass is in grams and not kilograms. In order to get energy in joules, we must have things in kilograms, meters, and seconds. So we're going to have to convert this from 3 grams to kilograms. We know that there's 1,000 grams to a kilogram. So there's 1,000 grams for every 1 kilogram. Grams cancels out, and we get 0.003 kilograms. Now we can solve for the potential energy. The height is already in meters, so we don't have to do anything with that. We get the potential energy to be 0.5886. That would be in units of joules since we converted to kilograms. Now it says to take 75% of that initial potential energy, and that will be the increase in the internal energy. So to find the internal energy, or the change in internal energy, I should say, we're going to take 75% and multiply by 0.75, the gravitational potential energy. This gives us a change in internal energy, an increase of 0.441. As always, units of energy are joules. So our increase in internal energy is 0.441 joules. So again, you just have to read carefully. It'll tell you what to do in the problem. In this case, we're going to take 75% the initial internal potential energy. So just read carefully as to how to solve.